My name is Thomas Watson. You can find me on GitHub as simply Watson because I was very lucky to sign up very fast when they opened. Not as much on Twitter, so I had to use a little imagination there. I work for this company called Opbeat. And at Opbeat, we do application performance monitoring for JavaScript. And so one of the things we do is we like to, when a request comes into your application, we like to break it down for you and show you exactly what goes on behind the scenes when that request is being processed. So what goes into the database and what is hitting a third-party API, et cetera. And this is some of the stuff I'm going to talk about today, but I'm not going to talk about what we do at Opbeat. I'm going to talk more about how you would want to do this yourself. So this is not going to be a product demonstration, I promise you that. At Opbeat, I'm responsible for the Node.js stack. So if you do npm install Opbeat, you install the code that I'm writing every day. So the topic of this talk is instrumenting Node.js in production. And as I showed you before, instrumenting, when I say that, what we want to do is we want to look at something like a request, for example. And we want to see what goes on behind the scenes. So normally when we talk about this, we see this kind of like a waterfall thing going on. And a lot of stuff can happen there. And the problem is it's really hard to figure out what request was active when we got to like the third stage all the way down in the machine room. And sometimes something happens down there, and we're like, okay, this broke, but what request was actually making that happen? Why did we end up there? What URL was called? What data was sent to the server? So these are some of the challenges. And the solution for for making this work normally is that either you have some kind of global or you have a singleton object where you store some kind of context. And that context includes, for instance, the requests that is active. And then you can always get back to that. No matter where you are in your application, you have access to this global context. Or another solution that I like a little more, but still have some problems, is you pass around the context between each function call. The problem with that, of course, is, well, you have to like do that all over your code. It is really tedious. But at least we get around some problems with having like this global thing. Before I get more into the details, I just want to run some vocabulary by you because I'm going to use these things quite a lot. When I say a trace, I basically mean a measure of time from something started till it ended. It could be like a database query or a call to an external API or something. And when I say transaction, it's basically just a collection of traces. So it could be a transaction would be like an HTTP request that have a lot of traces going on inside the HTTP request. But there is a problem, and the problem is called Node.js. I love Node.js, but it's really nice because you can run everything in a single process. But with that comes some problems, and those problems make it really, really hard to instrument. How many here are coding Node.js on a daily basis? And how many are new to Node? OK. So not all of you might know this event loop. So I'm going to just quickly show you what the problem is. So normally when you do a web server, a lot of the stuff is not actually processing stuff on the CPU. You're not like crunching prime numbers or something. You're usually waiting for a database to return or for doing some, writing some stuff to the disk. So there's a lot of I/O going on that actually the CPU is not really doing anything. So the only thing that's happening is the synchronous code that is running in these small blocks, and in between there's just empty space, just sitting around and waiting. And that means that Node.js can use that extra time that is there while it's waiting for a database to finish or something like that, and put in some other stuff that is coming in. So that could be like a different request that comes in. So it means that it can process multiple HTTP requests at the same time. That is really, really neat. But it means we have multiple HTTP requests running in our application at the same time all the time. So And oh yeah, and by the way, each of these pieces of synchronous code, you can think of them kind of like as a little piece of a program that has no recollection of what came before it. So when you enter one of these synchronous blobs, the code there doesn't really have a reference back to who actually put it there in the first place. So that can be really tricky to instrument. Another problem that we usually face in the Node.js community is, well, we like to use microservices because microservices are cool. And Node is lightweight, so it's really easy for us to build microservices. But the problem is that when we instrument this, we have an HTTP request coming in. It might be doing a couple of database queries. And then we see the result of the instrumentation. We see there's just like a huge HTTP request going on before we can respond back to the user. But what is going on there? We're calling a microservice inside our network, but we don't actually know what's going on. What's actually going on is it might be doing some database queries. Wouldn't it be nice to know those sort of things? And this is the same looking at it from a kind of a different point of view. You have your web application, and then you have a couple of microservices that it's calling, and those microservices might be calling other microservices. So you have this whole Christmas tree that you're trying to instrument, which can be really hard to trace the HTTP request over all these steps. So the goals that we want to make here, want to meet, is we want to track HTTP requests using these transactions. We want to instrument I/O, and we want maybe also in some cases to instrument CPU expensive operations or potentially CPU expensive operations. That could be JSON parsing, for example, which sometimes if you have a huge JSON object can take quite a long time. We also want to keep the context across requests to microservices, as I said, and we want to associate exceptions with the HTTP request that kind of made that exception happen in the first place. But we don't want to manually pass this context around in the app. That would be really, really irritating, and we will litter our code with a lot of stuff that is just ugly. And that ties into the second to the point below is we want this to be plug and play. We don't want to like add tracing, like start this trace here and end that trace there. We don't want to do that to our application. And finally, just to make it even harder, we want this to like not have an impact on our application's performance because we're running this in production. So the problems, as I said, is you have multiple HTTP requests happening all the time. It's not possible to associate an exception with the origin HTTP request. There is no API in Node where we can actually pass context across the async boundary. And how do we keep the context across requests to microservices? So the last point there, I'm just very, very quickly going to tell you, that has nothing to do with Node. This is just a very, very simple solution. That is simply, if it's HTTP request that is going on here, you could also have queues that where you're passing stuff to microservices using queues. But if it's HTTP requests, it's actually possible to go in and, I'm going to say a dirty word, I'm going to say monkey patch http.request. But just bear with me. And automatically add a transaction ID, an X transaction ID header to all outgoing requests. So that way that when the request ends up in your other servers, you can kind of, when you then later send that data to your, some kind of collection database where you store all this tracing information, you can tie these things back together and figure out what actually started up in the web application. And that other thing here, no API to pass context across the async boundary. I'm going to spend the rest of the talk making you guys believe that that will solve everything else. If we can just get that to work, we can solve everything else. We can solve the two things above there. And the solution is actually very, very simple. It's so simple that it's kind of stupid. It's a two-step solution. Every time something is queued on the event loop, so that was when you have the asynchronous code that is queuing something to be run later, we just want to record the context of where we are right now when we're queuing that callback. And when we then later restore or dequeue that callback from the event loop to run it, we want to restore the context that we restored when we queued it. So if you're talking transactions, consider we have like a global transaction object, and we seed it with the current request that is coming in, then the context in this case is just that property. So what we want to do is we just want to, every time we store something on the event loop, we just want to remember what was the current transaction. And when we restore that, we just want to restore the current transaction property to that value. So how do we do that? There are ways to do that now, today. Well, you have to monkey patch a lot of things today if you want to do that. And if you want to learn more about how you could do that in the current version of Node, come and talk to me afterwards. I don't have time to go into the details of that very, very messy code. What I do want to talk about is something called AsyncWrap, because AsyncWrap is a really exciting thing that is coming to Node very soon, hopefully. And it is actually that missing API that I was talking about that we don't have right now to pass state across the async boundary. AsyncWrap is a project developed under the Node.js Tracing Working Group by a guy called Trevor Norris. And you can go into this GitHub repo there, and you can see all the stuff that the Tracing Working Group is working on, along with the AsyncWrap stuff. There will also be documentation for the AsyncWrap stuff in there if you want to play with it now. And so let's play with it. So I'm going to show you some code here. I hope you're OK with that. But since this is new and this is not really in Node yet, there's no way to just require AsyncWrap like you would require HTTP or require net or whatever. But the C++ code for making this happen is actually there. And you can access that code by using process.binding. And it's actually already now in version 4 and version 5 of Node. It's shipping with Node, you just don't know it. But beware, this is like highly experimental and it will change. But you can play around with it. So you get back a AsyncWrap object. This is in JavaScript land. Then all you need to do is you need to set up some hooks. An init hook, a pre-hook, a post-hook, and a destroy hook, and then you just need to enable it. And now I converted my slides from Keynote to PowerPoint, so my transitions here are going to be a bit wonky, but let's see. So the 4 hooks are here. So the init hook will be called just when you queue something on the event loop, so that function will be called. You get a lot of variables or arguments, so you know what is being queued. The pre-hook is going to be called just before that callback is going to be called. So after it's being dequeued and just before the callback is called, you will get a call to the pre-hook. The post-hook will be called just after the callback have been called. And remember, everything inside the event loop when it's running the synchronous block is synchronous, so you know that the callback has finished running, and then the post-hook is going to be called. That callback might then queue some other stuff that will then call the init hook and so forth. But after the callback has finished running, you'll get a call to the post-hook. And then finally, in some cases, you will have a destroy hook when the garbage collector kicks in, that garbage collects this. This was me scrolling up, so you have the code above, and now we're trying to test this out. So we require the file system module, and we just try to open a file. That is asynchronous in Node. There is a callback to the fs.open that will be called when the file have been opened. And just before we write user before, and just after we write user after, and then when the callback at some point is called, it will write user done. So how will this work? How will this look together with the other code we saw before? Again, I'm sorry for the transitions here. So first you will see user before, because that's actually the first thing that is being run down here. Then you will see the init, because now we're actually queuing a callback. Then you'll see after, which is down below here. It's being, for some reason, cut out of the slide, but there's a user after at the bottom. At some point later, the file has been opened, and now we will get a call to the pre. Then it will actually call the callback and run the callback, so you will see done being written out. Then the callback is of course called. We will see post, and then finally we'll see destroy when it's garbage collected. How come I just didn't wrote console.log? In the past slide, I wrote just log. What is this magic log thing? What happens if I just use console log? Like normally you don't like log stuff here, but it's nice when you're debugging, especially this stuff, because it can get a little hairy. So what would happen if I wrote console.log? I get this nice error message. Fatal error, node AsyncWrap init hook through. What does that mean? Well, you would think that console.log was a synchronous operation, right? Turns out it's not. Console.log is actually asynchronous. So it means that when you go into the init function, because something is being queued on the event loop, the init function will call console.log, which will again call the init function, and you will have an infinite loop. So obviously you can't use console.log. So how do we get around this when we want to debug this code? Well, one way is to use the fs.writeSync, and the first parameter there is a file descriptor, and there's two magic file descriptors. In Unix, I think they work the same on Windows. One is standard out, and two is standard error, and then you can write bytes to that, and it will appear on your screen, and it's synchronous. The problem with that is it's just bytes. It doesn't have all the niceties that we're used to with console log, with all the formatting, all that stuff. So you would have to use your tilde format. It can get a little hairy when you're debugging to write all that stuff just to like output like some module that you want to, or some object that you want to see what it contains, right? So what I like to do is use this secret thing called process._raw debug, which is basically just a synchronous version of console log, but it's easy for debugging stuff inside AsyncWrap. So if we use that instead, then now we get the same output again. Good. So what's all these things inside the init function? You will have the this property, which will be set to what's called the handle. I'll get back to that. Then you have the UID, which is just an incrementing integer from the lifetime of your application. So it starts at 1 and goes up. And you will see the UID appearing in all the other hooks. So that way you can, when you have the pre-hook and the post-hook, you will, if you see the same UID, you will see that this is the same callback. So you can refer to the same callback across these hooks. Then you will have a provider. Currently, that's a number between 0 and 23. That might change. But if we look, you can always look at providers on the AsyncWrap object, and you'll see all these things. So the provider is actually who is actually right now queuing this. It could be related to making a TCP connection, or you can see number 17, that's a timer. So that would be like your set timeout or set interval that is trying to do this. And then in some cases, you will have a parent UID and a parent handle. If not, they'll be set to null, and in most cases, they're set to null. There are certain cases where they're used. I'm going to get back to that. So handle objects. What are handle objects? So I don't know how many people know this, but some of the stuff in Node is written in C++, and some of the stuff is written in JavaScript. And there's this magic line where JavaScript land ends and C++ land start. And you'll also see that V8 is also down here. So the stuff that is written in C++ is what's called libuv. And libuv is where all the I/O stuff lives. Because JavaScript as a language was born in the browser, didn't have any I/O. There was no talking to the disk or making TCP connections and stuff like that. So that when Node.js was developed, we had to make that in, from the bottom. And that is written in C++ and lives in libuv. So how do we communicate? How do we send data from the Node core down to the C++ layer? We use these handle objects. On those handle objects, we can set properties. So the data we want to pass across this boundary or back again, we can set that on properties on this handle object. So let's look at how that looks. This is a code lifted from the TCP module, or the net module, which for some reason is called net, but it does all the TCP stuff. And this is for setting up a new TCP socket. And you can see we use the same process.binding here, and opening up TCP wrap. We get two handle objects out, a TCP connect wrap object and a TCP object. And we instantiate them, and then we set some properties on them. For example, the TCP connect wrap, we set the address and the port we're trying to connect to. And this rec and this socket is actually the this. So that means that you can get the address and the port you're trying to connect to using the this keyword. And this is actually also an example of one of those cases where you have a parent handle. So in the case of you're making a TCP connection, first the connection will be made, and then later the socket will be opened. And when the socket is open, that's actually then the TCP connect wrap handle is actually the parent of the socket. So in those cases, you will have a parent, but it's very rare. Some things to watch out for. Here we have 2 timers. So how would we expect this code to look when or the output of this code to look when we run it? Well, before 1, then the init, because we are queuing the set timeout function. Then after 1, okay, that's cool. Then before 2, okay, that's cool. But then there's no init, and then there's after 2. So there's no init there. Why is there no init? And then after 2 seconds has parsed, we will see, oh, okay, now the pre-hook run for the number 1 there, and then the callback for 1 run, but then the callback for 2 run, and then the post hook, and then the destroy hook. And this is because Node is trying to be a little bit clever about this and not create too many of these handles. And in this case, the 2 timeouts both expire in 2 seconds. So it's like, I'm going to just reuse the same one, and so you will only get. So you have to be like, if it's important for you to get 2 calls to these hooks, you will have to do some things to make that work for timers in this sort of scenario. So just to wrap up with some gotchas here, the handle creation time can sometimes be a little tricky to know when that happens. So the handle creation time is the time where the init function is called. For example, if you have a TCP server, it's not calling the init function until you actually bind to a port, so until you call listen. That's when the init function is called. Console log, we already went through that. Process next tick is currently not covered by this, so you would have to, if you want to know when process next tick is called, you will have to monkey patch that right now. Timers, as I just said, there's some gotchas there. Promises, now we got promises in Node. Some people like that. Those are currently not covered by AsyncWrap because V8 doesn't really give us, so promises run inside inside V8, and V8 doesn't really give us any way to hook into these promises right now, but this is again something that we're working on, so hopefully that'll be part of the final AsyncWrap API. But maybe not, so watch out for that. And then right now, multiple AsyncWrap. So if you start AsyncWrap twice in your application, it will be the last one that takes precedence. So only the last one to add the hooks will be the one whose hooks are called. So those are some things to watch out for. And I have some code that I haven't showed you right now because it's showing you how to do some of this stuff right now without using AsyncWrap. You can find that and the slides on my talks repo on GitHub. And that's it.